Hello, this is Mr. Zanaletto again. I'm going to go ahead and go over topic 3B now. Again, topic 3 is segments and their lengths. Topic 3B is talking about creating an equation using the segment addition postulate and solve for missing segment lengths. So that is what right off our visible learning guide. And in this situation, we have 3B is really all about the segment addition postulate. And of course we need to know what the segment addition postulate is telling us. And the segment addition postulate says if point B if point B lies between points A and C, if it lies between points A and C on a line segment, then AB plus BC equals AC. And what does that look like in a geometric picture is if we had A, C, B's lying between it. It doesn't mean that it lies equally. These could be, B could be really close to A, B could be really close to C, but it lies somewhere in between it. So with that information, I wanted to go ahead and I had a couple examples already set up, but I wanted to go over the example we had already in our notes. In this situation, if n lies between m and p, I'm going to go ahead and draw my m, p, n lies between it. mn is 5. mp is 12. And we want to know what that value is. So this value and this value, well, the segment addition postulate tells us if we add 5 and x, we'll get the total length, which is 12. Subtract 5 from both sides, x equals 7. So that means NP is 7. That would be my answer for that particular problem. Following that same idea, point A lies between C and T. If I do that, I have C and T. I put A in between it. CT is 13. AC is 3. And they want to know what this is. So obviously this segment plus this segment, if it's all along a line, it's going to equal that 13. So using the segment addition postulate, it tells us 3 plus x must equal 13. So we subtract 3 from both sides, x equals 10. So that tells me AT must equal 10. That's the segment addition postulate. One more example. It's a little more complicated. They don't always like to give you just these numbers. Sometimes they get a little more complicated and they try to distract you when you really shouldn't be. H is between K and J. So I have K and I have J. I have a line between it. That told me H is somewhere in between. And I don't know where it is, but I'm going to go ahead and just put it right there. Now KH is 4x plus 2. And HJ is 7x minus 5. And all of KJ is 30. So we know this part plus this part equals the whole thing. So I need to state that in my equation. So I'm going to say 4x plus 2 plus 7x minus 5 equals 30. This is going to help me find x, and then I can plug it back in. This 4x and 7x gives me 11x. This plus 2 and minus 5 gives me minus 3. That equals 30. Add 3 to both sides. I get 11x equals 33. So obviously dividing by 11, x equals 3. So that gives me 3 there. Now, let's go ahead and state, now we want KH. Well, KH was 4x plus 2. Plug the x in for the 3. I get 4 times 3 plus 2, which is 12 plus 2, which is 14. So KH is 14. And now HJ is 7x minus 5. So I'm going to say HJ is 7x minus 5. Plug in your x. 7 times 3 minus 5 is 21 minus 5, which is 16. So HJ is 16. So I solved for x, and then I plugged in that x into my equation that I knew for KH and then the one that I knew for HJ to find their actual lengths. This was just a variable. These are actual lengths. And that is topic 3B. Thank you.